So basically what I want to do is go through a list of things that we have covered this year that I think have a somewhat decent shot of being on the SAT. Some definitely will, some have been on every few years or once every couple of years they put a question like this on there. And with this being adaptive this year, will it actually be on your test? I don't know, because not everybody's going to get the exact same test this year. So it might be on yours, but not yours kind of thing. So the things that we've covered this year that I'm expecting you to be able to do. If you see something like this, that could be a very basic question that everybody in here should know how to solve. Well, what do you use to, if you have an x in the exponent, how do you solve these?
Flip it.
Into?
Fraction.
No. Log notation. If your unknown is in the exponent, use logs. Put this in log notation, and it would be log base 2 of 17 equals 3x. This you should know how to solve. And remember, with one of these calculators, you could just use math, go down to log base, type in the 2 and the 17, and the last step would just be to divide by 3. Oops.
Oh, now you're
There.
doing 3.
I know. That divided by 3, and there's your answer. Okay? So make sure you know how to solve problems with the unknown up in the exponent. I don't think they'll throw anything crazier than something like that on there. But remember, you could also type this in like a graphing calculator as well. I mean, a longer way might be to actually graph 2 raised to the 3x. And then see when does this equal 17. So you could move the cursor up. Basically, what would the x coordinate be? You could use the trace feature and go over, get a pretty good idea of when does the y equal 17. It might be a little hard to use the cursor for that, but you get the idea. Okay? You could also use the Desmos calculator like we were working on last week to kind of do the same thing. So that's one thing. Do you guys remember how to do odd versus even functions? Last year, there was a problem on the SAT that looked something like, it said if f of x is odd and f of 4 is -7, what's f of -4? And you should just know the answer. Odd functions mean if you switch this, then the answer is just the opposite answer. So if it's -7 here, this would be +7. If they said it's even, then these two numbers should be the same. Does that make sense? They could also do it with sine or cosine. I've never seen them put that on there, but remember, sine is odd, cosine is even, so it works the same way. But make sure you understand what the heck odd and even functions are. They've also used cofunctions in the past. And remember, sine goes with cosine. And remember, it's always 90 minus. So these kind of questions they'll put on the SAT, and it should be a instantaneous answer kind of question. They're not going to be calculations you have to do. Remember, if it could be something like, if sine of 30 is a half, what's cosine of 60? Well, if you do 90 minus 30, you get 60, and sine goes with cosine, so these two answers should be the same kind of thing. The type of question I think they'll give you is more like the XYR situation. Like, these won't be nice numbers. They'll also make it to where you can't just type cosine of 60 into your calculator and get the answer, but you should be able to use the cofunction idea, and basically the answer should just be the same. Does that make sense? So make sure you know what odd and even functions do, and make sure you know how cofunctions work. Are we good on those? Okay. Every year, there's some converting questions on there. And they typically will do radians into degrees. There is always a question going from radians to degrees. Out of the last 10 years, probably 8 out of 10, there has been, and they usually put one of your specials on there, like 2 pi over 3, and have you convert that back into degrees. Do you remember how to convert radians to degrees? What's that? So how do you convert a radian to a degree? Well, you got to get rid of the pi, so you'd multiply by something with a pi in the denominator to cancel out the pi, and pi is worth how many degrees? 180, so what you're doing is multiplying by 180 divided by pi, and basically all you have to do is 2 times 180 divided by 3. Well, 180 divided by 3 is 60. 60 times 2 is 120. 8 out of 10 years, they have done that, where they will put not only a fairly easy fraction to calculate, but they will also put one of your specials, meaning the 30s, the 45s, the 60s on there. But that doesn't mean that's the only question that they will put on there. 2 probably out of the last 10 years, they've done something like this. They want you to convert this weird decimal into degrees. The idea is exactly the same. The weird part about this is the pi, the 3.14, just got multiplied in. Sure, I'll take that. I'll take some cake. What's that cake for?
It was like my couple for the Great Gatsby project.
Oh, okay.
So we made it out of cake so we could eat it.
Awesome, thank you. So, like, 2 pi over 3 can be put into decimals as well, where you just do 2 times 3.14 divided by 3. That is the same as 2 pi over 3, the 2.093 repeating. But we typically don't use decimals in radian form very, very often, but they are there and they are useful from time to time. So to convert this, you do it the exact same way. Well, before I multiplied by 180 and divided by pi. Well, that's exactly what I have to do. I just grab my calculator and I type in 7.314 and I times it by 180 and then just divide by the 3.14. And you can use 3.14, you could use the pi button to be a little bit more precise. Generally speaking, they use 3.15 as much as possible on the test. That way, anyone with any basic calculator can do this calculation. And that's your answer. The answer would be 419.3 degrees. So, you do it the exact same way.
No matter like the radian, you do it like that.
Yes. Just remember you multiply by 1. And if it's radians, you got to get rid of the pi, which means you're dividing by pi. If they do go the other way, and they say, what is 130 degrees in radians? Well, you do it the other way. You want to take that 130, You want to times it by pi and divide by 180. Well, this one, you're basically just doing this divided by this, reducing the fractions would just be 13/18, and you put the pi on top. If they want it in decimal, well, what is 13 times 3.14 divide by 18? And that's what it would be in decimal form. But, if that makes sense. Okay? So, I do expect them to put some logs on there. That's a chance. Sometimes they do, sometimes they don't. Odd and even functions, definitely. Be prepared for those. Co-functions. But I can guarantee you, basically, I think the majority of you will see a converting a radian into a degree problem. Will everybody? Probably not. I mean, I think it all depends on the first part. If you get to that, that means you're probably doing okay. Arc lengths. We talked about this a little bit last week. They do a lot of times put one of these kinds of problems on there in one way, shape, or form. Remember, if it's in radians, and they ask you for this arc length, or maybe they give you this arc length and ask you for the radius. Well, the formula is always the arc length will equal the radius times the angle. Just use that formula. So if I'm looking for x, it's the radius times the angle. Now, this formula only works if it's in radians. So if they give it to you in degrees, you can't use this formula. But we should also know how to convert a degree to a radian. So if they give it to you in degrees, just convert it into radian, and then you can use this formula. So in this case, all I would do is reduce that fraction, and the answer would be 6 pi. If they want it as a decimal, what's 6 times 3.14? Kind of thing. If they give you the arc length, and say the arc length is 8 pi, and they give you this angle, let's say is 3 pi over 4, and they want you to find the radius, you can do the exact same thing. It would just be the arc equals the radius times the angle. Well, how do you get r by itself? Instead of multiplying in this case, you're just dividing. And how do you divide by a fraction? You multiply by the reciprocal. So I would just do 4 over 3 pi kind of thing. The pi's cancel. And the answer would be 32/3, something like that. Does that make sense? So if you see an arc length question, think this kind of formula. The arc length will just equal the radius times the angle, as long as the angle is in radian form. So make sure we can do those. Most years, they will put an XYR question, or a question that you can solve with the X, Y's, R's. Sine is Y over R, cosine is X over R. Most years they'll put at least one of those questions on there. And typically, it's your table. They usually put numbers that are in your table. For example, they will put something like, if sine is 1/2, what is a possible value for cosine? Well, you could do this one with X, Y's, and R's. Like this is your Y, this is your R. Do the X squared plus Y squared equals R squared. Find your X. And you can find your cosine, because cosine is X over R. But if you recognize it, well, when does sine equal 1/2? 30. Well, what's cosine at 30 degrees? It's root 3 over 2. Boom. Technically, the answer here is plus or minus square root of 32 because I didn't tell you what quadrant we have to be in. Remember, sine's positive in the top two, cosine's in the right two. So if this happens to be in the first quadrant, it'd be the positive. If this happens to be in the second quadrant, this would just be the negative. But they typically don't put that on there. It's either or. So I would say no, just remember your table real quick, but also be able to use your X, Y's, and R's to do these kind of questions too, because there's nothing that says they have to. They could tell you if sine is 3/4, what's cosine, kind of thing. Well, now I would say that's my y over r. So I would do x squared plus 3 squared equals 4 squared. Figure out what my x value is. And 16 minus 9 would be 7. So x would be the square root of 7. So cosine is x over the r. And it'd be something like that. Okay? Are we good on those? Okay? They will have you solve right triangles. Every year, if you see anything with a right triangle, immediately look to see if it is the most common Pythagorean triple out there. 3, 4, 5. They always put a shortcut on there. No, 4, 5, 6 is not a right triangle. But they'll put a 3, 4, 5, and it might be as a 6, 8, 10. Or it might be as a 9, 12, 15. Those are all the 3, 4, 5 triangles. They use those because what they want is somebody that doesn't recognize it's a one of your shortcut ones. You can do it a long way. But if you recognize, oh, that's just a 3, 4, 5, then I can do the math a whole lot quicker in my head, and I don't have to do more arithmetic. It's just more of a shortcut. So look for the 3, 4, 5 triangle. My guess is they'll put something like that with a combination of the XYR stuff with the, if sine is 3 over 4, they'll put something like that. They'll say if sine is 3 over 5, what's cosine? Well, there's your y, there's your r. What's your x going to end up being? 3 squared plus y squared equals 5 squared. That's going to end up being 4. So the answer is 4/5. So they can use it in a combination with the sine and the cosine, but they'll put the 3, 4, 5 triangle shortcut in there as well. Make sure you know how to solve right triangles to find an angle. They'll say something like, this is 3, this is 5, what's this angle? Well, sine is opposite over adjacent, or a lot of times they'll do this. What is that angle? Well, if you know SOHCAHTOA, sine is opposite over hypotenuse. Well, 3 over 6 reduces to 1/2. When does sine equal 1/2? 30. So 30 would be the answer here. So they will also use the specials mixed into a actual right triangle story problem type of thing, or they'll put it in there, and if you use your table, you should be able to do it a lot quicker. There's nothing that says it has to be. Make sure you can do like the inverse sine or something like that to find those as well. But that could be on the SAT. Another thing that I will typically see on there is law of sines. I have not seen the law of cosines in a long time, but they will put something like this. And say, find this angle. Something like that. Well, sine of 100 is to 7, as sign of that angle is to 3. Butterfly, technically this is an ambiguous case, but I gave you an obtuse angle, so there's only one solution. So make sure you know the law signs as well. That's typically it. I've never seen anything on the SAT about like graphing, like when we did all the sine cosine graphs. I've never seen anything on there with those. That doesn't mean they won't throw a question of which one of these has a period of 2 pi or 4 pi, but odds are they won't. I've never seen anything with trig proofs on there, but that doesn't mean they couldn't throw a quick identity question at you of, and if they are, it's pretty much guaranteed to be like a sine squared plus cosine squared equals 1. So it doesn't mean they won't throw that at you, but I've never seen it on an SAT. Honestly, that's as much of what we've covered that I expect to be on this SAT. For the most part, go in with the idea of I'm just going to do the best I can. Are there going to be questions on there that you don't know how to do? Yeah. Do the best you can. If you're completely stumped, see if you can plug something into that Desmos calculator and see if it'll spit something out of a graph that you think kind of makes sense as an answer, at least help you guess and check. Use those sliders on the Desmos calculator. I think that'll help too. But that's all I got. Does anybody have any questions for me on the SAT?